I'm Priscilla Barrera with the Investing News Network, and here with me today is Simon Morse, who's Managing Director at Benchmark Mineral Intelligence. Simon, thank you so much for joining us today.
It's good to be here, Priscilla. Thanks for having us.
Yes. So today I wanted to start by talking a little bit about Tesla's Battery Day. And my first question for you is, what do you think is the main takeaway from that event in terms of how much it could impact the battery metal space? And I guess what surprised you the most?
Yeah, so I think the main takeaway for me is that Tesla are officially upstream. This is kind of a phrase that I used online and on Twitter. But what I mean by that is it's the first time an automaker, electric vehicle maker, but an automotive maker, period, has moved into the upstream of the lithium-ion battery supply chain. So what we've seen over the last, well, probably since 2015 is automakers have started to dabble with the battery manufacturing stage. So they've realized, Tesla were the first to realize very quickly that Panasonic aren't going to make enough battery cells for their ambitions. And then they obviously in 2016-17 were speaking with LG Chem, and they were the second partner they got on board, but they realized that they had to, do more, and building a gigafactory was one, but this is the next stage. And so for me, the number one is Tesla is officially upstream. A really important part of that is Tesla now looking to build chemical plants, cathode plants first. So the step before the lithium-ion battery, and then of course lithium hydroxide chemical plant, and also they're looking to rejig the nickel chemical step in this. So for me, in summary, it's this: Tesla are officially upstream, the first automaker to actually want to get into lithium production as well. That's crucial. And I think for me, this is the biggest part of the battery day.
All right. So let's talk a little bit about the different aspects. And I wanted to start with the cathode side. So Cathode Improvements, what do you think realistically Tesla can achieve? And what do you think is their biggest challenge ahead, I guess, in the time frame they set?
That's a good question. So cathode, Tesla didn't give many details on their actual cathode production step. It was clear they want to reduce costs. It's clear they've identified cathode manufacturing and the inputs, especially on the nickel side, as areas they can cut cost and cut steps. So this is Tesla's strategy that they've brought in from the downstream of initially reducing the miles a lithium-ion battery travels by building the gigafactory. They've brought in this first principles supply chain approach to the upstream. And so I do think that it makes complete sense to build a cathode plant in Texas, next to the Terafactory. The biggest component of that is energy input costs. So, if Tesla can control their own plant, even just have a plant that for 25% of their needs, for example, and they can then really reduce that energy input stage, in addition to the margin that other companies would make, and also the logistics costs, then that's a significant sort of portion of the cost of a battery they can reduce. Single-digit percentages maybe, but at the same time important. And then the next and most important thing with cathode really wrapped into this is the very few details they gave on the nickel side. So the only we don't know the details of this yet, and be interested to see if Tesla do actually, or if this is a concept stage. But the concept is very interesting. So the concept is you take nickel metal and you take it direct to the precursor, which then goes into, obviously, next stage of that is the cathode. But the key is to eliminate the nickel sulfate step, eliminate that need to turn it into a sulfate, eliminating energy, reagents, saving cost, and making the whole supply chain shorter. So, it might have been a rambling answer, but the principle of the answer is that the details are still light on the ground here, that we need more details, but it's a very interesting sort of stage in the supply chain and a reasonable chunk of their strategy to reduce cell cost.
All right. And on the anode side, so the other side, they're going for silicon, which seems like a big goal. Can you explain why? And is the EV market really saying goodbye to graphite?
Goodbye to graphite? Absolutely not. No, that's not the case at all. It is very interesting. So the silicon anode thing. I mean, Priscilla, we've talked about this for many years, and silicon has always been knocking around in the graphite anode space. The reality of what's happening, before I get into the Tesla side of the discussion, is silicon is used in lithium-ion battery anodes. It's between 3 and 6%. You can call that an average of 5% if you want to do your spreadsheet numbers. That's a good number. And it increases the energy density. Of course, the problem with silicon is it expands significantly, and the whole battery breaks apart. So pure silicon anodes are as difficult as solid state batteries. So it's been around since the early 1990s. The research started, I think, in 1992, and yet to be cracked by many, many academics. So Tesla didn't say 100% silicon anodes, so I want to make that clear as well. They did give, the numbers were based on the premise that it would be a very high percentage of silicon in there, like way above 80%, something like this. But it's very difficult. So unless their process to coat the silicon particles works at scale and works in an electric vehicle, then graphite's going to be here for a long, long time. And so in summary, we were ready to congratulate Tesla, because we got the buzz that the anode focus it's a really important focus of the battery, because everyone talks about cathodes and no one really talks about the graphite and the anode side. So much improvement you can do there, including making the graphite supply chain much more resilient and better as well. That's a separate topic. But in summary, we were going to congratulate Tesla on getting to double digits. We thought, if anyone can put 10% plus silicon in a graphite anode, it would be Tesla, and that would be groundbreaking. And so we were ready to kind of go, yeah, this is really interesting and cool. But then, typical Tesla style Elon Musk, they jumped in with 2 feet and promised the world. I would say watch out for 10% plus silicon in terms of an industry average. Tesla might come out with something wild, but the question is that representative of the whole market? Is it also representative of all of Tesla's cars? The answer is probably no on both, but it's definitely an area to watch. And as a result, I think anodes are back, silicon is back, and graphite's back. So you're going to need all three.
All right. Let's just then jump to another raw material, which is lithium. There's a lot of talk about the lithium space after Tesla's Battery Day. And obviously we heard them announce that they had rights to lithium-rich clay operation in Nevada. Now, is there a reasonable explanation to why they will go for a clay operation, given it hasn't been commercially proven?
Honestly, I think it's because it's in Nevada. I think that's why Tesla have always been keen on lithium in North America. You have to bear in mind that Tesla dabbled with lithium from geothermal sources way back in the day, right? You remember Symbol Materials and the approach, the clandestine approach that Elon and Tesla made for Symbol back in 2015, maybe 2016, something like this. But of course, you had Symbol had been working on that since 2009. I remember Luca, who started that company, and we were discussing about the potential back 2009 in the Atacama Desert when we went to see SQM. So that's how far these memories go back. And for Tesla, I think that it's clearly a strategy move to say, okay, we're looking at the raw materials now. We've staked some land. Industry, let's say not the industry, but the financiers for the industry, invest in new projects. We're going to need a new supply of lithium, or we'll do it ourselves. And so that's a good message. It's a very strong message. Tesla will be slowed by the supply of lithium, will be slowed by the supply of nickel for batteries. Raw materials, especially with now its terafactory numbers, which are astronomical, raw materials are clearly the problem. Despite the message they attempted to give us that they're easy, it's not the case at all, right? So I think Nevada clay, which is because it's in Nevada, it's not commercial yet, obviously, but the industry is looking to companies like Lithium Americas, which is Lithium Nevada, to push that forward, and they're the ones to watch really on this, not Tesla. And so I would say that's the key thing. Now, the second part of this is which we released in an exclusive was the lithium hydroxide chemical plant, which was it was alluded to by Drew in his on the stage. Drew was the other guy, the VP of cell manufacturing and or the engineering, but it wasn't detailed. So I think this is more important. This is lithium. Tesla want to build next to the cathode plant in Texas a lithium hydroxide facility that uses spodumene concentrate as the feedstock, which then makes sense why they've signed a deal with Piedmont Lithium, the developer. Very interesting. So the North America angle coming back in again. I think Tesla are going to be getting their lithium from spodumene first, not clays. And clays will be, they're going to develop it and see what happens, I think. That's much further down the line.
All right, so let's just talk about the feedstock then for that plant. Do you think acquisition of junior miners is still on the cards, or we're just going to see more of the Piedmont Lithium type of deals until Tesla figures out how to mine lithium? And I guess my question is there a point for them to become a lithium miner?
Good question. I don't think Tesla will ever become a lithium miner. I think they will sensibly understand that mining is a completely different skill set. In fact, chemical production is still a completely different skill set to what they're doing, but they're putting their foot into that area. So that's really interesting to watch. It's one thing Elon doesn't really differentiate to his followers and to investors is that chemical engineering is different to the engineering that they're used to. And so many things can go wrong. The barrier for entries are really high. Not all feedstock is the same. Consistency, quality, all of these issues are constantly having to be balanced, which is why I don't think, which is why it's interesting that they've gone into the chemical stage. But of course, you'll gain a lot of knowledge from that. We'll see what happens. But then digging the material out of the ground, I just don't see an automaker, unless something drastically happens and they just cannot get the feedstock. They cannot get the spodumene from Australia. They cannot get Piedmont to be to raise the money to go into production. Unless something really just puts a complete blocker on getting the raw material out of the ground, there's no reason for Tesla to get involved in that stage. But as a result of them building the lithium hydroxide production facility, number one, it's the first ever automaker to get into lithium production, which is crucial. That's like going back to 120 years ago and saying, looking at the start of the oil industry and how that was impacting car industry back then. It's that kind of watershed moment that you'll look back on in 10 years time and realize. So that's crucial. But yeah, I just can't see them getting into mining.
All right. Now, another thing that we saw them announce is that they want to source all of the raw materials in North America for its North American operations. And we also saw just last week, President Trump signed this executive order and declaring a national emergency to expand the domestic mining industry, in particular critical minerals. Now, would you say is the U.S. taking the right steps to build resilience in their supply chains? And what do you make of these announcements?
They're taking, they're making the right noises. Mm-hmm. The right noises is a bit harsh, maybe. The right discussions, conversations are happening. We know that much from the Senate testimonies that I've given over the last 3 years. The question is whether that turns into action. And at the moment, the industry is still waiting for any clarification. Now, I've actually always thought that, the best action the government could take is to deregulate certain areas and make special concessions for new lithium mines, cobalt, nickel, graphite, manganese, all these key raw materials that go into not just batteries and EVs, but let's call them 21st century industries that have been earmarked as really growth engines, especially post-COVID. I think the US can earmark these and make it a lot easier to not only build these mines, build processing plants. They could also give loans, free or cheap land. It's something the Japanese government does very well, for example. Yet the US is very disjointed on the whole thing, different regulations, different states. And it makes the whole planning for this blueprint much harder. So the US has to build, right now, the US has got 9 battery mega factories in the pipeline, and China's got, in total it's 167. China's got about 120 of them, in the pipeline. So the US is well behind. I'm not saying the US needs that many battery plants, but they're going to need a lot more. They're going to need what we call an order of magnitude bigger, and to build this whole supply chain, and a lot more than really the press release from the White House is needed, because the US has to decide whether it wants to be a player in the 21st century auto industry, whether it wants to be a major player in really energy storage, which is going to be the biggest disruptive factor on the energy industries ever. And so does the US want to help and build this blueprint domestically? If it does, then actual firm action needs. It needs to also help its lithium miners, its cobalt developers, build more domestically, and more importantly, build this ecosystem, cathode plants, anode plants, exactly what Tesla have done, but on a wider scale.
Right. And now, question for the investors that are watching us today: do you think, or is there one misunderstanding or maybe a wrong assumption that they might be making after Tesla's battery day about this space that maybe needs a better explanation?
The wrong assumption would be it's easy. So obviously lithium and nickel chemicals that go into batteries and graphite anode, and that obviously are all functions of supply and demand. We understand that. But then as a result, it's very easy to spreadsheet these things and then say, well, it's clear that this year will be oversupply and this will be undersupply. Well, it doesn't matter what's produced. It doesn't mean that lithium that's produced will be able to go into a lithium-ion battery. This is a high-spec chemical engineering industry. A lot can go wrong. Far more can go wrong than can go right. As a result, the barrier for entries are high, and things go wrong and things get delayed. As you know, Priscilla, you've been covering this for a long, long time. I mean, look at the work you did back years ago, right? I mean, everything gets delayed and most doesn't get funded at all. So I would say for investors of old, and as a reminder, and investors of new, it's not easy. It's a long-term investment. It takes 7 years to build a lithium mine at best, to fund and build a lithium mine, should I say. And it takes 18 months to build a battery plant. So for me, the takeaway is it's not easy. It takes time. You need integrated partners on this, as Tesla is now proving, because it's kind of going and doing it itself. But if you have all of these combination of things like a battery major, an automotive OEM, a good asset, and management that understand, all of these things, then you have a good investment prospect. But again, don't expect money tomorrow. This is there'll be outsized returns in 10 years time if you invest now. And I guess investors aren't used to that short-term horizon, but maybe COVID is changing that. So we shall see.
Chelsea. So my last question for you today. Now, did any of the announcements made by Tesla make you maybe rethink your outlook for the EV space or even for raw material prices?
For raw material prices, maybe, because of the size of the Terafactory and the speed of the fact they're building that quicker than Berlin. And that obviously started, I'm guessing now, but it must have been a good 6 to 8 months after Berlin. So the speed of the Terafactory, which we expect to be up and running in 2022, Q3, Q4, and then ramping 2023, that is a new layer of demand for the industry, for all raw materials, right, and especially lithium. And so I think that brings forward negative forecasts. Let's say it's positive news for what was negative because of the COVID situation. But as I said, it's as a result of what's happened on Battery Day and the Terafactory plan, the story still is Tesla and China. Of course, you've got General Motors coming in with LG Chem in Lordstown. So it'll be interesting to see roughly around that time what happens. So you can see a few more. Tesla's scaling in 2022. China will be increasing, and you've got GM in North America coming into the game around that time as well. For me, that's positive news for raw materials around this time. And bear in mind, if the plants are operating in Q4 2022 or 2023, then they'll be having to acquire the raw materials a good 6 to 9 months earlier. They'd have to be having the conversations a good 18 months earlier. So all of this points to activity again. The next level, the next step up in in demand for the electric vehicle space and for everything associated: lithium, graphite anode, cobalt, nickel, manganese. What have I missed? I think copper as well. Throw copper in there. You're going to need copper, right? A lot of it. So, yeah.
All right. Thank you so much for joining us today, Simon.
Happy to be a part of it, as always.